It's time we talk about regions and availability zones, and we'll touch upon edge locations as well. As you can see in this diagram, we're in AWS region US East 1. And inside of that region, there's multiple availability zones. So what is a region? What is an availability zone? We'll get into that with some analogies in the next slide, but in a nutshell, a region is a giant geographic location. So it's an independent geographic area. The US East 1, there might be one on the West Coast, there might be one in other countries. There's tons of regions to pick. And we'll go into why you would pick a certain region over another, mainly due to proximity of you and proximity of your audience. I really like the college campus analogy. Each building inside the campus is like an AZ. So each building would have its own independent power, independent water, infrastructure needs, all that. There's over 120 AZs across 39 geographic regions, and each one is 100,000 to 400,000 square feet. So it's a massive, massive amount of data and infrastructure just to support this. So even though the buildings are independent as far as power and water and infrastructure goes, they're so close that you can have these massive fiber optic cables between them. And so there's low latency and high bandwidth, highly redundant networking. Now to go from one region to another, that's a different story. It seems like it's painfully slow compared to the AZ to AZ. So keep that in mind when the test asks you if it's fast or slow to go from one region to another versus AZ to AZ. AZ to AZ is much faster. All right, so think of the edge locations as the neighborhood pickup center. It's like located very close to the students, at the dorms or at their apartments. Every student doesn't need to go back to the college campus to pick up the popular materials. Instead, there's a copy nearby. Essentially, that's what CloudFront does. It stores copies or cached copies of the content at these edge locations very close to the users. If it has a copy, it'll gladly give it to you. But if it doesn't, then CloudFront will help you retrieve it from the origin. So basically back at the main campus or the AWS region. The important part or distinction to remember is that the neighborhood or the edge locations are not the same thing as AZ. You do all of your compute, you launch all your EC2s, your instances, all inside of the AZ. Just to be clear, edge locations are not really limited to static content. There are CloudFront functions and Lambda at edge that execute code near the viewers. Keep in mind that the EC2 instances and the VPCs are not deployed at CloudFront edge locations. Okay, now imagine the college campus has two different buildings. Each have their own power, cooling, network connections, all that good stuff. So if building A loses power, then the other building can remain open. Everybody can go over there. It's still good. That's the idea behind deploying across multiple AZs. So the load balancer is what's checking to see which building has power, which one's ready to go, and it automatically detects it through the health checks, and it routes everything to Zone B. No student will go to Zone A. They know it's closed, and everybody's happy in Zone B. And I know it seems far-fetched, but this is why you have a server on each AZ. Don't put both servers on the same AZ for resiliency. You're going to learn how to decouple and error-proof and replicate all the important things to make sure your application stays up and running. So a common trap is treating edge locations like any other AZ, but just remember they solve completely different problems. In AZ is where your workload actually runs, the compute, the EC2 instances, that's where you launch them. It sits inside of an AWS region, and it's where you deploy resources. Like I just said, EC2, subnets, databases, applications. You use multiple AZs to provide the high availability, so you have duplication. Just remember that an edge location is part of a separate global network. It's not part of an AZ or a region. It is separate. There's probably hundreds and hundreds of edge locations. Just remember that availability zones, the AZs, that's what runs your workload. That's where your EC2s go. That's where your databases lie. When a user requests content through CloudFront, the request goes to the nearest edge location. That's what CloudFront does. It checks its local cache to see whether it's already got a copy. If it does, all the better. It's called a cache hit, which is a good thing. That means it can serve it right away to the user from that edge location. It serves it faster, way faster than if it has to go to the origin. So if it doesn't have the actual cached copy, that's called a cache miss. So then CloudFront goes and retrieves it from places like the S3 bucket or a load balancer, whatever web service returns, whatever web service you're using at the time. And then it'll store that copy for future requests. So if you request something more than once, it'll automatically have that cached copy at that point. Allegedly. So in a nutshell, CloudFront improves performance in how many ways? 2. It serves the content closer to the users, and it reduces repeated work at the origin. So it gives your origin a little break. Okay, just know that everything has a trade-off. There might be a transfer charge you have to think about. And then region to region, it might be much slower, but it might be a good idea for disaster recovery. And again, you have to look at the cost between region to region, how often you're doing it. Do you want it to be synchronous or asynchronous, once every night, once every month, whatever the case might be? Those are all trade-offs. So every question will have some sort of trade-off, and they're going to emphasize, hey, we want low latency, and we don't care about hurricanes, right? So that would be AZ to AZ. You might replicate between the two.